Okay, so we saw the definition of a tensor product in the last lecture. Now we will see some more examples of how to calculate tensor products. Alright, so suppose I have a state. Write it first. Samples. Okay, so I have a state u. Suppose I have, this is 0 plus 2 1, and I have a state v which is 3 0 plus 1. Okay, so what is the tensor product of u and v? Alright, so the first vector, the components of the first vectors are 1 into 0 times 2 into 1, and the components of the second vector are 3 into 0 times 1 into 1. So their tensor product is going to be 1 3 1 2 3 1. Okay, so this is going to be 3 1 6 2. Alright, okay. So what if we wanted to invert our vector? I mean that suppose I had I have a column vector of the composite space. Okay, I have a state of the composite space, a state of the composite space. Okay, the state is of the form like this: 1 1 2 2. Okay, I need you to find the states of the individual system. Find the states of the individual systems. Okay, so how should we approach this problem? Well, let's go back to our definition. We basically need to find two states u and v, which if we take the tensor product of these two states, then we will get this. Okay, so if we go back to the definition of our tensor product space, so this is equivalent to 1 into 0 0 plus, well, let's give a and b for clarity, 1 into 0 1b plus 2 into b plus 2 into 1b So in order to product out, we can do this. Okay, we can write this equal to, consider the first two numbers, consider these first two parts. So we can write, if we take the 0a common, you see we can take we can take 0a common between these two things. Here is a 0a and here is a 0a. If we take that common, we get 0a. Okay, we get 0b plus 1b. Alright, and consider the next two numbers, these two numbers. We can take, oh, I did a mistake, this will be a. Alright, we can take 1a common. So if I take 1a common, actually I can take 2 common as well, so I can take 2 into 1a common and get 0b plus 1b. Alright, and now you see that I can take this thing and this thing is the same, so I can take this common as well. So I can write the product as zero a plus 2 into 1a times 0b plus 1b. Alright, so this is our vector u, this is the vector u, and this is the vector v. Okay, if you want to recheck, you can take the tensor product of these two vectors and you will retrieve the original vector. Okay, you will retrieve this original vector. So in this way we can form tensor products between two vectors to find the composite vector of the composite space. And if you have the composite vector of the composite space given, then you can retrack your steps and find the individual vectors that that you get from factoring the composite vector. All right.